Okay, so now we're looking at matrix multiplication, or where we're multiplying a matrix by a matrix. So if you look here, we're talking about, I have, say, matrix A, and I'm multiplying it by matrix B. Okay, so the first thing you need to do is to make sure it's defined or possible. And to do that, you have to look at the order. So I'm going to pretend, so if matrix A has an order of, and I'm just putting in letters. So I could say, for example, matrix A could be an order of a 2 by 3. Okay? Then you have to look at your matrix B. Now, for you to be able to do the multiplication, what has to happen is the rows in the second one, B, need to match. So can you see what I'm saying? These two numbers need to match. So they were both the same number, and then it can be whatever. But these two numbers here, are what's going to be the answer. The answer will bring an order. So you might see them like this, but often they write, you might want to change this, they call it AB because they've multiplied those two together, so we'll call it AB, yeah? So for it to be possible, the rows, the columns in the first matrix must equal the rows in the second. Now, so for this to be possible, so often they'll ask you, is this matrix multiplication, is it possible, and why so? Is this defined? They might say, is it defined? And you say yes. You have to write this statement, okay? You can't write draw the line and say they equal. That's not cutting it. This is one of those ones where they're going to ask you for particular wording. So see this thing here? This is going to be what you're going to write. Except you may be changing, so I'll just highlight it in yellow. Don't write A, don't write A, because write whatever your, whatever the matrix is, whatever the first one is, okay? All right, so if we have a look at these matrices here, so this is our example. So if I write the order underneath this one, this is 2 rows by 3 columns for that one. This one's 3 rows by 1 column, and this one is a 2 by 2. Okay, so there's that's been done there. Okay, so if we had a look, if we multiplied A multiplied by B, that's going to be possible because A is a 2 by 3 and B is a 3 by 1. So it is called defined, so we can do it because those two are equal. And the answer, when you have AB, the answer is going to have an order of a 2 by 1. Okay? And that'll be the answer. The answer will look like a 2 by 1. It'll have 2 rows, 1 column. Okay, so that's what we're saying. So then if we go and have a look, if we do matrix B by matrix A, so here we've got a 3 by 1 and then a 2 by 3. This is not defined, so you can't do it. So we would just say you can say B cannot, it's not defined. Just write not defined. So in matrix, order is extremely important. So really what we're saying is A times AB is not the same. So we might write the statement that AB is not the same as BA. Yeah, they're different. They won't work. So where in other maths where you've seen, where you see 1 times 3 equals 3 and so does 3 times 1 equal 3, that's in normal maths, it doesn't matter. Like in that, but in matrices, extremely important order, which one's coming first is thing. So just to summarise what we just said there, when we've got our orders of our matrices, these two numbers must equal. They must be the same, and these two will give you the size of the new matrix. If you try doing it on your calculator, which we can, but we're going to learn manually. But if you do it on your calculator, it'll say undefined if it's not the right order, okay? So you will be told. You won't be able to go any further, okay? All right, so if we have a look, it says here's A and B. So it's in matrices, it comes really handy just to always pop the orders underneath the matrices as you see them. So this one's a 2 by 2, this one's a 1 by 2, and this is a 2 by 1. So they're asking you which of the following are defined. So we did A by B, so that one is not defined. B times A, in this case, it is. So because it's defined, and it'll have its answer of that 1 by 2. That's where they're getting that from. Now, when they did C times B, that is defined, and its answer will be a 1 by 2 because we're taking those outside 2. And then CA is also defined. Oh, 2 by 1, sorry. We wrote this wrong, didn't we? So let's just fix that up. So C is actually a 2 by 1. A is a 2 by 2. So they're not defined. That's where it's saying it's not defined, okay? All right. So just in summary, like what we said before, order's important. So order in multiplication, in matrix multiplication is important. So which one's coming first and which one comes second? All right, so now it becomes crucial. We need to know how to manually multiply matrices and how it's worked out. The most common one to fully do is like we've got the one there, 2 by 2 multiplied by 2 by 2. But you can get asked to do it. Now, everyone goes, oh, we can just pop it in our calculator. Yes, you could. But they have ways of asking you where there's no other way unless you know how it's done. So they know you've got your calculator, so they're testing that you know how to manually do it, all right? So we need to learn. So first of all, you come up to your matrix and you write your orders down. So I'm going to multiply these two matrices. So I check that they're defined. I can do it. And then what I do is I like to then write the order of my answer. So my answer was going to be a 2 by 2, okay? So what I like to do is I like to draw out a matrix with the empty boxes so that I know that's how many answers I need to have, all right? So the way you multiply is one way some people talk about it is they say you run and you dive. So can you see that A got multiplied with E and then you add B being multiplied with G. So if you look at your answer, if you look at this cell is row 1, column 1. So can you see that when I was working it out, I'll work it out a little bit bigger. So in this first spot, I have because this answer is row 1, column 1, that's what I've used. I've used row 1 with column 1. So I've gone A times the E plus the B times the G. So down here, I'm in row 2, column 1. So I would be doing this row by this column. So it'll be C times E plus D times G. Okay, so you run and dive. If I went to change, so I want to do row 1, column 2. So I'd be over here. I'm doing row 1, column 2. I've got A times F plus B times H. Okay? Can you see that's what's happening? Yeah? So there's the go. So let's go and do these ones underneath so we can have a go. So first of all, I'm going to multiply this A times B. So I'll check the order. it's a 1 by 3, and it's a 3 by 1. So is it defined? Yes. So we know it's defined because these two are equal. What will my answer be? Yeah, it'll be a 1 by 1. So sometimes it's just easier to go, right, I should just have one answer at the end of it, yeah? So if you think we've got row 1 with column 1, so it will be 1 times 2 plus 2 times 4 plus 3 times 1. Can you see what you're pretty much taking these three and you multiply with those three and add them together? All right, so if you simplify that, that would be 2 plus 8 plus 3, which would be 13. Okay, so let's do this one down under here. All right, so I might just draw it a little bit bigger. So let's just test. We've got a 2 by 2 and a 2 by 1. What will my answer be? Good. So 2, 3. So my answer's going to be a 2 by 1. So I'm going to have an answer there, 2 columns, and 2 rows and 1 column. All right, so let's have a go. So we'd go up here, I'm in row 1, column 1. So I'd be multiplying row 1 with column 1. So it is 1 times 2 plus 0 times 3. Okay, this guy is row 2, column 1. So I'd be using row 2, column 1, and it'll be 2 times 2 plus 3 times 3. And then you just tidy those numbers up. So we've got, up the top, we've got 2 plus 0, so that'll be 2, and I've got 4 plus 9, which would be 13, and there's my answer. Is it a 2 by 1? Yep, so I've done it correct. All right, so it doesn't matter. This one is the same, really, isn't it? It's a 2 by 2 with a 2 by 1. So my answer is going to be a 2 by 1. Good. Now, if you have letters in there, doesn't matter. You just do the same process. So I've got this row by that column, that's my first one. So it'll be 1 times x, which is x, isn't it? 1x plus 3 times y. I can't add those numbers together, so that element just stays like that. And what would the next one would be? Because you've got row 2 times x, so we've got 2 times x plus a negative 4y. Can you see that? And so then you can't add them. They're different numbers and letters, so you just leave it like that. So your final answer just has like that expression there. That's actually an element in itself, just like that, and that's fine. Okay? All right, so we've been looking at manual multiplication, and we saw that when we do run and dive, and so really the row gets times with the column of the second matrix. So there's these matrices that we can say where we call it a summing matrix. So what you're going to do is you're going to times it by like you've got, say, this matrix here. So this displays, it's got, so we've got 1, 2, 3, 4, we've got 5 rows. And what they want you to do is they want you to do a multiplication, so multiply it with another matrix that will end up being that you add up all these rows. So what you'll find is, so if you look at this matrix, this is a 5 by 5. Now, if you want to have a matrix, so this would be the answer. So can you see if the answer, if I want to add up and have a sum of all the rows, I would have 5 answers here with all the, all the 5 rows added up. That's what they want. So you can see if this is the order that I want for my answer down here, I want a 5 by 1. What I'm going to need to do is you can have a look. Well, for me to be able to multiply this first matrix with something else, it would have to be a 5, wouldn't it? It'd have to have 5 rows because that's the rule. And then if you look here, we want 1 column. So that comes from this spot, doesn't it? So there's the 5 came from there. So that means I need a 5 by 1 here, okay? So when we go to work it out, if we were working this out, we would go, all these numbers multiplied by that, and then you add them up, because that's what you do. Because here, over here, this is row 1, column 1. So what do you need to multiply something if we just want to get it itself and then we want to add it? So what number do you think I need to put there?
1.
Yeah, 1. So if I had 1 all the way down here, can you see this one in here would be 2 by 1 plus 4 by 1 plus 1 by 1 plus 7 by 1 plus 8 by 1. Can you see I'm actually essentially adding it all up, aren't I? Because I've got a column matrix thing. So if you want to add up the rows, so you could write a little note here. If you want to add up the rows in a matrix with using matrix multiplication, you post multiply. So post multiply means after. So you multiply after by a column matrix of 1, yeah? Of 1s. Okay, so here I've post multiplied to add up if I want to add up the rows. Yeah, so if I want to add up the rows. Now, if you look, sometimes they say, well, what could you multiply to add up the columns? So that's different here. So if you look down here, I've got another matrix and I've got 1, 2, 3, 4, I've got 5 columns and we want to add them up. So really, I want all those 5 columns in my answer. And I just want 1 because I'm adding up, what I'm going to do is add up all these numbers. So you can see my answer needs to be a 1 by 5. So what you can see, for me to be able to do that, here I've got the 5. So for this to work, that means this would have to be a 3, yes? Is that correct? And then I need a 1. So I'm going to have a 1 by 3. So a 1 by 3 means I have 1 row and 3 columns, yeah? So if I want to add, can you see if I put 1, 1, 1? So if I do this first answer, this is row 1, column 1, you can see what I would do is I would be multiplying those ones with that. So it'll end up with being 1 times 4 plus 1 times 0 plus 1 times 4. And can you see that added up the columns and we would get 8 there. Can you see how that adds that up? So if we want to add up, or the sum, they say sum of, just means if we want to add up the columns of a matrix, and they'll say, we want you to multiply it to add up the columns. What we're going to do is we're going to pre-multiply, you'll hear them say pre-multiply, with a row matrix of 1s, okay? So that's how you can add that up. Sometimes it comes up and it'll make it a lot easier if you realise, if you've probably got this. So question 8, the table below shows the information about 3 matrices. So the transpose of A, for example, is written as AT. They're just emphasising that fact. What is the order of the product of this? So what they're doing is you've got to find out the order. So it's like they're multiplying all these matrices. So first of all, what I would suggest is we find the order of, say, AT. Now remember, when you transpose a matrix, its columns becomes its rows. So if I transpose this one, it'd be a 4 by 2. Can you see I'm just flipping them around, aren't I? Yeah? If I transposed B, what would it be? It will be a 3 by 2, and if I transpose C, it'll be a 4 by 3. Okay, so now I know the orders of those transpose matrices, just to make my life a little easier. All right, so now we've got to look down at what they've done down here. Now, like all maths, we should do the brackets first. So I'm going to do what's in the brackets. So we had the matrix, I'll just write it like this. We had matrix AT and we multiplied it with matrix B, and we would have got an answer. So if you look at the order of AT is a 4 by 2 and normal B is a 2 by 3. So when you do that and you get, so what I'm doing is I'm doing this part and we're going to get an answer for the order. So they're equal, but my answer will be a 4 by 3. So now I know that this bit is at least, I've got a matrix sitting in there that's a 4 by 3. Okay? Now, we then want to transpose that because there's a little t there. So what would that be?
3 by 4.
A 3 by 4. Good. So we've done that. And now we've got to multiply with this CT, which was a 4 by 3. So this is CT, and this is the answer of all of that. So it is able to multiply. And what will its answer be? A 4 by 4. So there's our answer. Okay, so let's look at this one. Matrix A has 3 rows and 2 columns. So I just like to probably write it out. So I need to visually see it. So I think it'll make it a lot easier. And it says matrix B, so I'll just write it like this, has 4 rows and 3 columns. Okay, matrix C equals B times A has, so if you're going to multiply B by A, we're going to see a 4 by 3 multiplied with a 3 by 2. And what they're saying is they're going to call it C. And what would C's order be? A 4 by 2. So it would be 4 rows and 2 columns, which is D. Let's go. Question 2, the West Horn Council must prepare roads for expected population changes in 3 locations: the main town, the villages, and the rural areas. The populations of these locations in 2018 are shown in matrix P below, and the expected annual change for each of the locations is shown below as well. So it says write down which P 2019, which shows the expected population in each location. So if you've got to increase main towns by 4%, that means you need to times this by 1.04. If you need to decrease villages by 1%, you need to times it by 0.99. I'm reducing it, and if I need to decrease rural areas, I'll need to times it by 0.98. So we'll do that on the... Okay, so we've done that and we've created that matrix. So you just had to times that out like that. And then it says the expected population in each 3 locations in 2019 can be determined by this matrix product here. So what they've done is they've multiplied to get this P19, which you've got up above there. So let's just write its order. It is a 3 by 1. So they said to get that, they multiplied this matrix and then by this matrix up here, which is also a 3 by 1. So let's break it up. We've got to work out what F would be. So what I'm going to do is I've got matrix F and I had to multiply it by P 2018, and it gave me, they said, was P 2019. So I know that this is a 3 by 1, and I know that this is a 3 by 1. Okay, so that means F would have to be, because they've pre-multiplied it, it'd have to have a 3 there. And what will it have to have in the column? In the rows, sorry. This would have to be a, yeah, because we're getting this. It'd have to be a 3. Okay, So now I know that F is a 3 by 3. So I'll pop that in like that because it'll make it easier for me to work out. Okay, and then I'd multiply it by the 2018, which was this. Okay, and then it gave the 2019. So really, which was this, 2184, 1782, and 1660. So if you look at it, this was the main town, villages, and rural areas. So when I get this answer, I want it to do only with main town. So this is row 1, column 1. So I'm going to be using this and this. Now, I said I only want to talk about the rural part, isn't it? Because that top bit. So I don't want any of these numbers to be affected. So if I write 0 and 0, those two numbers will be multiplied by 0 and they will be eliminated. Now, what did I need to multiply that 2100 to get it up to the 2184? So in here goes 1.04. Now, in the second row, in the villages, I only want the villages to be affected. So that would be this middle number, won't it? So I'm going to put 0.99 in there, and these two will be 0. Because when I multiply this row with this column, see how the 0.99 will be multiplied with just that 1800. And then what would the last one will be? I want 0, 0, and 0.98. So just to tidy it up, this is what I believe F to be, is we've got 1.04, 0, 0, then 0, 0.99, 0, and 0, 0, and 0.98. Okay, there are two rides, the Big Dipper and the Terror Train at a carnival, and the cost in dollars for a child to ride on each ride is shown below. 6 children ride once only on the Big Dipper and once only on the Terror Train. The total costs in rides. Now, here you've got to be careful because they want the total cost in rides in dollars for these 6 children. Total cost, that will be one answer, won't it? Is that true? It'd be one total answer. So if that was in a matrix form, it would have an order of a 1 by 1, wouldn't it? Because you'd have the total cost in this matrix form of a 1 by 1, okay? So using that can help you decide. Because this is, if you look at the matrix multiplications, first here, this is a 1 by 1 getting multiplied with a 1 by 2. What will that give me? That will give me a 1 by 2. That won't be what I want, isn't it? So straight away, I can get rid of that. I can get rid of this one, yeah? Because this is going to have 2 columns. Get rid of this thing. And now I'm down to these ones. So let's just double check this one. So this would be a 1 by 1 with a 2 by 1. It's not even possible, is it? No? So now I'm down to this one, which is a 1 by 2 and a 2 by 1, which is possible and will give me a 1 by 1. And if you look at it, it will work because you'd go this row with this column, 6 times 7, 6 plus 6 times 8, that will give you the total cost, isn't it? Yeah. Sometimes it's worth you logically working out what the answer should be, and you could have tested them, and that's another way to test you got the right answer. But that way, I didn't really even have to calculate it. Very quickly with the orders, I could see which one was right and which one was wrong. Okay, so with this one, 4 matrices are shown below. Which of the following matrix products is not defined? So just quickly pop the orders there, 3 by 1, 2 by 3, 1 by 2, and 3 by 3. So which one's not defined? W and Y would be a 3 by 1 and a 1 by 2, that's defined. X is a 2 by 3 with W, a 3 by 1, that's defined. Y is a 1 by 2 and X is a 2 by 3, that's defined. Z is a 3 by 3, W is a 3 by 1, of course it's the last one. Z is a 3 by 3 and Y is a 1 by 2. This one is not defined, so E. The table below shows the number of each type of coin saved in a money box. The matrix product, so matrix product just means we've done a multiplication of two matrices that displays the total number of coins and the total value of these coins. So in the end, if you think about it, we need two answers in our thing, don't we? And so we could have possible orders could be a 1 by 2 or we could have a 2 by 1. Yeah, because I need to have two answers. So let's go, if you have a look through these, this is a 1 by 4 and a 4 by 1. This is going to give me a 1 by 1. So I'm getting rid of that combination. Yeah? If I look at this one, all right, so let's go to look at B. So B is a 1 by 4 and then a 4 by 2. So this is going to give me an answer of a 1 by 2. So let's have a look at what it does when you quickly manually look. So I take these numbers. So these numbers are the number of coins, yeah? And I would go this row with this column. So what does that do? That adds up all the number of coins, doesn't it? Yes? Yeah. So I'd have in this 1 by 2, this would be the number of coins. So that looks okay. Now, but if I do the next part and I go row by column, that would mean I'd be timesing 15 by 5. So that's correct because I've got 15 5-cent pieces, isn't it? Yeah. Yeah? And then I'd be timesing 32 by 10. So this is adding up the value of the coins, isn't it? So this looks good to me. So I'm going to go with that. If you look at the other one, this way, they're adding up the names of the coins. So that doesn't work, okay? So we needed the quantity there. Which set of it, so here we've got a matrix multiplication. Which set of equations could be used to determine the values of A and B that are shown? So if you have a look, you look at things like when you're multiplying. So say for example, I would multiply this row by this column, and it would be, because that's row 1, column 1, it would give me the answer over here. So this is a 2 by 2 and this is a 2 by 1. So we're going to have this bit to answer will be a 2 by 1. Okay, we'll do that one first. So I'll go this row by this column. So that first row will be 6 times 2 plus 3 times B. Yeah, and then the second row will be like that. So it'll be 2 times 2 plus -1 times B. So that, I've just worked that out. And now I'm going to go over this side and do this one. Now this is a 2 by 2 and a 2 by 1. So it will also produce a 2 by 1. And your first thing would be 3 by A plus 4 times 3. And your second option there would be like that. So it'll be 1 times A plus 2 times 3. So I'm going to tidy these up. So really on this side, I've got 3A plus 12. And I've got A plus 6. And I'm saying it equals 12 plus 3B and 4 minus B. Okay, so can you see what you need to do is this spot is equal to that spot. So I could say 3A equals 12, yeah? So A equals what? Or I could say, yeah. Or I could say, oh sorry, this is 3A plus 12. This is a 2 by 2, isn't it? Yeah, sorry. Yep. Rub that out. Rub that out. So what we can say, this is a 2 by 1. So this is a whole element there. So I can say 3a plus 12 equals 12 plus 3b. Okay, so then I could divide everything by 3 there. So I could say a plus 4 equals 4 plus b. Yeah? And is that an answer? Or you could bring that, I'm going to bring b over here. It'd be a minus b equals 0. Is that one? Yeah? It is. So this is one. And is there another one that has that? Here? Yeah. So let's look at this other option here. So where I can say a plus 6 equals 4 minus b. So they've got a's and b's on the same side. So I'm going to bring the b over there. It'll become a positive, and I'll bring the 6 on the other side, becomes a negative. So a plus b equals negative 2. Is that another option? Yeah, here. So there's my answer. Okay, the matrix product, this is equal to, this is pretty easy. So I've got a 1 by 3 and a 3 by 1. So what should my answer be? A 1 by 1? It's just this guy. Done. Sorted. In the next question, the element 24 in matrix AB is correctly obtained by calculating. So you have to say how you work that out. Now, because that spot, that number 24, is row 2, column 1, that means what I did is I went with, to work that out, I used row 2 with column 1. So it was 4 times 3 plus 2 times 6. And where's that answer? That is here. B. Okay, the price in dollars of 3 different televisions for 3 different major brands are shown, blah, blah, blah. The retailer is about to discount brand A by 10%, brand B by 25%, and brand C by 15%. So if you're going to discount something, you're going to reduce the price. So all these all this A brand, you're going to times that by 0.9 because it's discounting by 10%. All this B brand, what are you going to multiply by? 0.75 because 1 minus 0.25, yeah? And then what will you be multiplying these by? 0.85. Beautiful, 0.85. So if you think about, they say which of the following matrices would give the discounted price in dollars for the 3 different size TVs and the 3 different size brands. So your answer, it still needs to be a 3 by 3. You still need to have the 3 brands and the 3 categories. So you could quickly go, this is a 3 by 3 with a 3 by 1. Is that going to give me a 3 by 3? No, get rid of that option. And I've looked down. So it's going to be the other ones. Now, we remember we want to multiply. So if you look here, we've got all this A, and we want to multiply that by 0.9. So when you go, if I go across and I go, sorry, change colour. If I go this row by this column, that is going to give me this first answer, which should be brand A at the 40-inch and at 90% off. Can you see that? That's going to multiply that A by 10. That's not going to work, is it? No. So which one do we look down? So, yeah, if we just, move it up. This one looks good because I'll go row by column. So only the first number is going to be affected, and then we have a 0, 0. Then if you do this row by column 1, you can see that this guy is going to be by 0.75. So you're right, E is the answer.
Miss, what about D?
D, let's have a look. So D, if I go row by column, that is going to work. Now if I do this row by this column, why is it not working? Because you added up 0.8. Sorry, because this one, when you do this row, you're going to times this by 0.9, but that's got to be 0.75, okay? This is how, you can just do multiplications in the calculator. So it's pretty obvious. You just type your matrix out, you times it, and type the other one out, and it'll do it for you. If it's undefined, it'll tell you. It goes, it can't be worked out. And then if it can, it'll do it for you. Just last thing, let's read through some examiner's tips on this. Students need to be able to articulate why two matrices may not be conformable for a multiplication. So that is that blurb. So that's when you must say, because the rows in, the columns in the first matrix equal the rows in the second matrix. Okay, so that was that blurb that I told you. So if it is able to be multiplied, that's the reason. If it's not, you say because they're not equal, okay? Many students have illustrated poor understanding for the need of number of columns. So what they're saying is kids often do like what I've been telling you, like when we're quickly working it out. So say like this, they'll say, why can't you multiply A and B? And kids will just do this. Idiots. And you won't get the mark. So what I have to say here is I have to say A and B cannot be multiplied because the columns in A does not equal the rows in B. Okay?